Hi, I'm Dr. Nicoletti, and I wanted to post this video so that you have some examples of how to use Venn diagrams to test for validity when you're looking at categorical syllogisms. So the first thing I want to sort of review from a previous section is that you have to make sure you know how to do each of the four standard propositions, what the diagram is for each of those. So for the A proposition, you know that the S is shaded out. Everything that is in S but isn't also in P is shaded out because the shading represents that that's empty. For the E proposition, you have shading between the S and the P. For the I proposition, you have an X here because that's to say that there is something and it is an S and a P, so we represent that with an X. And then some S or not P, we put an X out here because that shows us that there is something that is an X, but it's not a P, okay? So you want to have those by your side, or you want to have those memorized when you're actually doing the testing categorical syllogisms. You have that third term there, but you want to make sure, but you're really essentially still just diagramming the relationship between two categories. Okay, so I pulled these examples from the book. I think this was like number 4 in 5.2, all high fat diets or diets high in cholesterol. You can find that one. And then what I did is I took it and I put it into, I reduced these long terms into capital letters. And then once you have that down, you can use the Venn diagram to test it for validity. And I'm going to do that on the board in a second. I just wanted to put a couple things up here, and you could pause it on the frame if you want to take a look at what is up here. So a couple things. It doesn't really matter what capital letters you use as long as you're consistent. So if you used H for high-fat diets, then you have to have H wherever you have high-fat diets, and the same for the other letters. So you might have different letters, but you should still have the same letter here and in each of these. You should only have 3 capital letters, and you'll use each of them exactly 2 times, okay? Now when we get to testing this for validity, just a couple of notes that Hurley has in the book, but I figured I'd point them out here. You do not diagram the conclusion. We never diagram that. We're only diagramming the premises, and then we look to see if by diagramming the premises, is the conclusion also on the diagram. Always, if you have a mix of a universal, A or E, and a particular, I or O, or again, all and some, whenever you have a mix of those in your premises, you always diagram the universal premise first, okay? So even if that was here, we would diagram it first. And then you're going to see in a minute that this one is invalid, but I wanted to make a note also. Whenever you have an X on a line, which means you couldn't determine whether to put it in here or here, or here or here, whenever you have an X on a line, ultimately the argument is going to be invalid, okay? So you can already imagine if you had 2 particular statements, you're never going to be able to determine that one, which area they go in. So anytime you have 2 particular statements, it's going to be invalid. Okay, so let's take a look at this one. So I do have it here. It says all H are D, some D are not F, some F are not H. So whenever I do my diagram, and once again, as long as you do it right, and you have 3 circles, and you have each of your capital letters, your category that represent your categories, it doesn't matter where you have them. The main thing is you're trying to figure out if the argument is valid or invalid. It doesn't matter where you have them, but I just make as a rule for myself, and I think Hurley does this, I usually make my circles this way. You could make them, this way also. It really doesn't matter. But I always make them this way, and I put the subject of the conclusion here, and the predicate of the conclusion in this circle, because once I'm done diagramming it, then I'm always looking at the same place. I could just look straight across to see if the conclusion is on the diagram. So first thing, we're going to start with all H or D, And we're basically just using those 4 original diagrams. We're just going to kind of ignore the F circle right now. So if you were looking at all H or D, then if you look at the diagram for the universal an A statement, you know that you will diagram it this way, right? So I'm looking at these 2 circles, and then I diagram it so that anything that would be an H that is outside of D, is that part's going to be shaded, and you just sort of ignore that line there and you go over it, because you're just doing everything that is an H that is not a D. And then some D are not F. So if you were looking at the original diagrams, or when you just have 2, you know that you have some S are not, I'm sorry, I'll put a D there. So some D are not F. So now we want to take a look at these 2 circles here. And it's a little bit backwards, but we're basically going to make this diagram on this diagram. So if you look at some D are not F, you know that you need an X out here. However, in this case, because nothing is shaded, you don't know whether that thing that is out here is also an H or not. Okay, remember this is deductive logic, so you can't make that assumption, so therefore you have to put it on the line, okay? We know that it's out here somewhere, but we don't know if it would be here or here, so we put it on the line, okay? And now we just want to look at the conclusion. Again, we don't diagram it, so you're just going to look at some F are not H. Now if you were looking at that on its own, sorry, keep making that S. If you were looking at that on its own, you know that that's an O statement, and so you're going to have an X out here. However, when we look at this, right, we don't have that. We don't have an X over here, so we know then that this one is invalid. Okay? So again, you diagram the premises. We diagram the universal premise first when we have a mix, because sometimes we'll see that forces you to put the X in a certain spot. In this case it didn't, so that was undetermined. And then because we don't have the conclusion diagrammed here, it's invalid. Okay? Alright, so let's try another one. So very quickly, I have another one in the book, but this one says, number 16. These are all from 5.2. It says, all currently living dinosaurs are giant reptiles. All giant reptiles are ectothermic animals. Therefore, some ectothermic animals are currently living dinosaurs. So I have all C or G, all G or E. Therefore, some E are C. So let me erase this. I'm going to put it up here. And you can see my diagram on the paper, but it's nice to see it as it's done instead of just looking at the completed one. So we have all C or G. And again, if you're doing this and you use different capital letters, that's fine. You just want to make sure that you use, whatever the letter represents, you're consistent. Okay, so we have all C or G, all G or E, some E or C. So once again, put your 3 circles. Unfortunately, I'm not the best circle maker. And then, as I was saying before, I always put the subject and predicate letters, terms, on the bottom, and then my third term will go up here. Okay? So again, I'm not going to diagram the conclusion. You ignore it for the moment. And I want to refer back to those original diagrams when I diagram the premises. So we don't have a particular statement here, we just have two universals. So it doesn't matter in what order we do them, but I'll just start here. It says all C or G. So I'm going to shade out anything that's a C that's outside the G. And again, remember, all of this is a C outside of G, so you just ignore that line and you diagram right over it. Okay. And then the second one, all G or E. Now I'm going to look at the G and the E circles, and I'm looking at all of this out here. Okay. So now I want to diagram all of that. Okay. And now I just use the diagram to determine whether it's valid or invalid. And this is some E or C, and of course, in order for that to be valid, you'd have to have an X somewhere on this diagram. So this one is invalid. If you've read in the book, they talk about the Aristotelian standpoint and the Boolean standpoint. And I think I've said a number of times in the learning module, we're not going to do the Aristotelian. Remember, for the Aristotelian, you not only have to diagram this, but you also assume there is something that is a C. And so you would, if you were going into the Aristotelian standpoint, you would have X's on the diagram. But for the Boolean standpoint, we can always have universal statements, and it doesn't mean there's anything that exists that has those qualities. So this one would be invalid from that standpoint. All right, let's try one more. I think I have one more with a particular statement. Okay, so this one, I don't think I wrote down which one it is, but it starts, no spurned lovers are Valentine's Day fanatics. Some moonstruck romantics are Valentine's Day fanatics. Therefore, some moonstruck romantics are not spurned lovers. So you can pause on this to see how I did my diagram, but I'm going to put it up here. So remember, you always want to keep your standard, the form for the standard proposition. So you want your no are, some are, and then the last one was an O statement. Some M are not S. Okay, so I have no S or V, some M are V, some M are not S. And then we'll just diagram this one. Let's see, we have MS down here, and then we have V as our third term up here. Okay. Okay, so once again, we have a universal and a particular mixed. So again, we don't diagram the conclusion. We're just going to focus on the premises right now. Since we have a mix, we want to diagram the universal first. The order does matter here. And then we'll diagram the particular statement. So no S or V. I'm just looking at these two circles here. And what I want to do is shade the overlap between S and V, because that area is empty, since no S or V. And then now I have some M or V. So if you were looking at this on its own, we have M and V. We know that from the standard form propositions and their diagrams, you would have an X in the overlap between M and V. So if you look here, now in this case, you know that you have this overlap between M and V. That's the overlap. Now because this is shaded out, we know it's empty, we have to put the X in here. So now you can see why you do the universal first. Once you do the universal, it may determine where that X goes. So now if we want to determine whether or not it's valid, we take a look to see we have some M are not S. Okay, that's the conclusion. And if you were looking at that on its own, you would have an X over here. right? Because there's something that is an M that's not an S. And now we just want to see whether this diagram represents that. So if we look here, we're looking at this entire area where we have M outside of S. And we do have this on here, right? It's up over here, but it is on there. So since the conclusion is on the diagram, it means those premises entail that conclusion, right? By diagramming the premises, you also diagram the conclusion, so you know that this one is valid. Okay? Okay, so try the homework. In that one, you don't have to reduce the terms, you'll just be given these, and then you'll have to determine whether or not you have to determine what the diagram would look like, and then you will make a judgment about whether it's valid or invalid. And hopefully this lecture helped.